I welcome all of you in this particular webinar. In this, we have chosen a topic, importance of cloud in IoT, or the necessity of cloud in IoT. So that particular topic has been picked up from this IoT and cloud domain. And in this particular session, today, tomorrow and day after tomorrow, we'll able to see different ways that how we can relate this IoT with cloud computing. So let's go into the introduction part of IoT. First, we'll understand what is IoT, and we'll see different components related to IoT. Actually, what makes IoT so much popular nowadays, and everybody is working and everybody is doing their research work in this particular field as a buzzword. So I'll go into that slowly, and then we'll move on to cloud, and we'll see actually real-time examples of this particular cloud. So if I'll go into that particular part, that is one sentence, it tells many things, like IoT has gradually transformed the way daily tasks are completed. Now, if we'll say that I am not associated with IoT, I'm not using anything related to IoT, so it is actually completely wrong. Means everybody nowadays somehow associated with this. And if we'll talk about, let's say you are using Ola and Uber, right? You are using Zomato and Swiggy, different applications. All these are the applications of IoT. If we'll talk about smart watches, like I have one smart watch here. I have the smart camera. If we'll talk about, or somebody talk about a smart home, right? In Bhubaneswar, we have smart transportation system is a part of smart city right now. And let me tell you one example of IoT and how this daily tasks are completed nowadays using IoT is we have the city bus service, and that is called MoBus, and this all the buses are connected to the internet, and we have an application that is the MoBus application. If you'll install that particular application, based on your current position, it can tell you that where your next bus will come, and at what time, what is the expected arrival time of that particular bus in your bus station, and how much time it will take you to the destination, and what are the different movement of different buses. So all those things are there, and it is working very fine, and this is a great example of IoT. If you'll order anything from Swiggy and Zomato, you can able to see where your food is right now, and this is also example of IoT. You are using Ola, Uber, you can see your car, where your car is right now. This is an example of IoT. So here, if you'll see, you can see here I have so here I have a device. So this is a device called Alexa. What is the time? Alexa, what is the time?
The time is 11:19 a.m.
Yeah, so this is an example of IoT. If I'll ask him, like, Alexa, what is your name?
My name is Alexa. I find that it's a great conversation starter.
Alexa, what is the weather today?
Currently, in Bhubaneswar, Odisha, it's 33 degrees Celsius with mostly cloudy skies. Today, you can expect some sun.
Okay, Alexa, stop.
With a high of 36 degrees and a low of 26 degrees.
So this is an example of IoT, and we are actually surrounded by these type of devices. And with this particular device, I can actually make my home smarter. If I'll say to switch off a light, or if I'll say switch off on a light, or if I'll say switch off a TV or switch on the TV, increase the volume, it can do that, right? So it is making our life easier, and actually we are surrounded with these type of technologies. Now, these type of technology are in our daily life, but these type of technology are there in our professional life also. So there are many other examples that we'll discuss later on. First, we try to understand that what is the use of IoT.
Hello.
What is the use of IoT?
Five. I request all the participants to mute yourself. I request all the participants to mute yourself, sir.
Okay, thank you. So we'll go into that. Let's talk about definition of IoT, that how we can define what is IoT is. So Internet of Things is an ecosystem of connected physical objects that are accessible through the internet. Now any physical object, whether it is a living object or non-living object, if you want to connect it to the internet, that is making an ecosystem to actually build an IoT infrastructure. Now here the thing could be anything, as I told you, living or non-living thing. If a person is attached with the heart monitoring system, or some sort of smartwatch, so it is an example of IoT. An automobile with built-in sensors are also an example of IoT. So the object here, we have to assign the IP address to actually connect to the internet, so that it will send its data to the internet and receive its data to the internet without any manual assistant. So what I want to say is, it can do, the IoT can do many things, and definitely if we want to connect any object to the internet, we have to connect that object to the IP address, and we have to give some IP addresses to connect it. Now you would ask, like, can we connect anything to the internet? So my answer is yes, we can connect anything to the internet. Now the second question will be how we can connect, right? How we can make a particular thing to be part of IoT. How we can say that if I have an object and I want to make sure that the object will be connected to the IoT, then how it is possible? Now here comes some questions again. If you have any object and you want to connect that particular object to the internet, then first question is why you want to connect. So the answer is, so this particular question will come up with two answers, and IoT also gives two facilities. The first answer is, I want to connect an object to the internet so that I can monitor it. What I can do? I can monitor it. Second thing, I want to connect an object to the internet so that I can access that object remotely. So there are two things, and generally we do two things only. So IoT is a big thing, and IoT infrastructure, many people are saying about IoT, but it will do only two things. First, it will, whatever object we have, we can monitor that object, and second, we can use that particular IoT infrastructure to control or to access that object remotely. Remotely means I'm not physically here, but I can access those devices through the internet. So that is the two work that will be done by IoT. The second thing is why has been finished, and how we actually do that. So to doing that, we have only two things. That is, The first thing is we have to connect any of the object to the sensor first. Now, what is a sensor? So sensor is an important component of IoT. How it is important component of IoT? So if you see this particular slide, we have many sensors available. Like we have ultrasonic sensor, we have a smoke sensor available, we have human body sensor, sound sensor, vibration sensors. So right now we have lots of sensors available with us, and all those sensors will help us for monitoring. So how it will do that? Let's say I want to connect a chair to the internet. So what type of sensor is required and why? First of all, why? So if I want to connect my chair to the internet, so definitely what I want to do, I want to monitor it. Like my chair is occupied or it is not occupied, right? So if I'll say that my chair is occupied, then how I get to know that it is occupied? So we have to put some sensors over there that will tell me that whether the chair is occupied or chair is not occupied. Okay. Now the second things comes into the picture, and I'll slowly go into that particular direction where you can fully understand what is that. Let's say I want to connect my whole house, and I want to make a fire alarm system. So I have to put some sensors, which will, let's say, the flame sensor or the smoke sensor. With the smoke, it will give alarm, and I can get to know that that is alarm came actually. So what I am doing, I'm monitoring my room, right? I'm monitoring my room with that particular smoke sensor, whether there is any fire in my home or in my office or in my room or not, right? So that easily can be done, that very easily can be done. If I want to connect my appliances to the internet, so I have to put some sensors over there so that I can identify like my appliances is on or off. And this is one thing, the monitoring is one thing. The second thing comes is, and we have many things for monitoring, is we have to use sensors. If I want to monitor anything, any object, I have to use sensors. Like we have some more sensors available here, like PIR sensor, ultrasonic sensor. Now there are some soil sensors available, IR sensor available. Physically, if I want to show you, we have different sensors available. It's able to see that we have many sensors which are available, and you can make use of all those sensors which are available in the market, and you can actually connect anything to the internet. And it is very easy, very much easy. I'll show you how it will be easy. Now the next thing is, I told you that how we can monitor anything. So we have to monitor any object, that whether it is working or not, it's on or off, whether it is occupied or not, or is there any motion somewhere. If or let's say if I have a smart camera, so or a smart CCTV camera, so what it will do is it will capture the image, video, whenever there is a motion, it will find out. So all these are different example of IoT where we have to do one thing, that is monitoring. The second thing, as I told you, to access. If I want to access anything, any object, let's say I want to access my door. If I want to access my door remotely, means I want to open my door remotely. If I want to close my door remotely, then I have to use another device which is called actuators. So you see we have many DC motor available. This is again servo motor, which is a linear servo motor. It will go into a linear direction, and this is all uh, uh, the traditional motors available. So all these motors are useful for as an actuator. So with that we can access it, and we can actually make it to do something. Let's say I want to connect my door to the internet. So why I do that? The first thing, so the answer is I want to close and open it, and I want to monitor whether my door is open or my door is closed. So I can monitor that thing, my door is open and door is closed, with the help of sensors. But if I want to access it, means if I want to open it or if I want to close it, I have to use actuators. So there are different type of actuators available in to make any application of IoT. We have some relays. Relays are useful for, these are also an actuator which is useful for appliances, any electronic appliances. If I want to uh, on and off my TV, I want to on and off my fan, I can easily do that remotely with the help of these actuators. So let me tell you what they are, and actually all the actuator need, they required power. First thing, they should be connected with some power sources, and second thing, they should get some signals. So some signal is, let's say if I have a relay is connected with the power, and we'll give the signal to on and off. Let's say if we have a actuator, and this actuator or a linear servo motor is connected with the power, and will give the signal to go up direction or go down direction, right? Or if we have these motor, we tell that you go to clockwise direction or anti-clockwise direction. So it is all based on two principle. One is we have to give the power, and second we have to give the signal. Now here the question came, we have learned about sensors. Sensors are used for monitoring any object. So we have different type of sensors we have seen. We have seen actuator. So actuator will do, let's say I'll take an example. We have a street light in our campus, okay? And what I want to that street light is, whenever there is a intensity of light is lower than a particular value, so my street light should on. And whenever I find out the intensity is less, my street light should off. If the intensity is more, the street light should off. It means in a daytime my street light is not going to on, and in the night time it should be on. So what I'll do that, so I'll use a sensor, let's say the light sensor. From there I can find out the intensity of it, and based on that I can give the signal to these actuators to on and off that particular street light. And I can easily do that. If you want to connect this to the internet and you want to monitor each and every street light in your campus, you can do that very easily. You can do that. We'll see how actually all these are possible in real life. That example we'll see later on. Now the second thing came, can these sensors that we have seen, these are all the sensors, right? There are some pins, right? You can see at least three pins should be there with all the sensors. Two pin is for power, and one pin where the data will be fetched from these sensors. Here also we have at least three pin available in the actuator, where we'll give the power and one pin for the signal. Now, if I am sending the data from the sensors, and if I want to give signal to this actuator, then there should be some computing device which actually do that, right? So the third type of component which is required to make and enable, make IoT infrastructure enable and working, we should have some sort of microcontroller or microprocessor. Now we have different type of microcontroller and processor available. Like this is called Arduino Uno. This is a type of microcontroller available with us, where there are different pins. These are all different pins. These pins are useful for connecting the all these pins are useful for connecting the sensors and connecting the actuators. This is a very common, you can say, Arduino Uno board. Second is, this is Node MCU board. here also you can see there are different pins available. These are all different pins available. And this is also a microcontroller where we can connect some sort of sensors and the actuator with it. This is ARM microcontroller. This is another type of microcontroller. Means different companies are making different microcontrollers. This is a type of onboard chip or onboard computer. Raspberry Pi is a whole computer, right? Here we have all those things, and we have different pins by which we can actually connect sensors and the actuator with it, and we can do programming, and we can enable any object to be connected with the internet. So all these devices are required, all those devices are required to connect any sensor or any actuator, and we can enable any object to connect with the internet, okay, with these devices. So it is not like one object, we give the IP address to the object, it is connected to the internet, or it will send and receive the data. No, it is not that much of simple, but we'll see that how it can be done. So as I told you, these are all microcontrollers which are used to connect the sensors and the actuator with it. And these microcontrollers are programmable microcontrollers. So we can do some programming on it. So based on our program, it will work. And whatever function we'll give to that particular uh, microcontroller, it will act based on that particular function and based on that particular program. So here, definitely we have to give power. So this is the way we can connect. This is, so these are all what you can say port which are useful for giving the power to it. Okay, and so in the Raspberry Pi and yeah, so in the Raspberry Pi and Node MCU, we have the facility of connecting these devices to the internet. This Node MCU and ARM. So we have to have some communication module. We have to attach it so that we can connect and communicate to the internet, as well as both 2 or 3 devices can talk to each other. Now here, if we'll talk about the whole IoT infrastructure, IoT infrastructure has actually 5 components, and it is very important to know all these components very well. And these are all integral part of IoT. So now let me tell you, IoT is not one technology. It is a combination of many technology and become a IoT infrastructure or IoT concept, you can say, or IoT architecture, you can say. So IoT is not one thing. Okay, that thing you have to remember. Now let's talk about the 5 component or 5 essential component of IoT. Means if I talk about IoT, these 5 components should be there in that particular IoT infrastructure. Otherwise, if we are saying IoT, then it is wrong. So there are some automation type of thing, and some devices are automated. That is not IoT. If I want to automate any device, it doesn't mean that it is an IoT infrastructure. IoT infrastructure is if we have these 5 components with it. So let's start this component of IoT and try to understand what are those. So the first component of IoT is thing or device. So thing or device means anything or any object that you want to connect to the internet. So what I told you, we need some sensors, we need actuator, and we need these microcontroller to be enabled, right? And these this particular part is called the sensor network. This particular part is called sensor network. Why it is a sensor network? Because if I'll take an application of, let's say, the fire alarm system in any building, So all those sensors are actually, we have to place in every room, or maybe 2 or 3 sensor in one room. So those sensors, let's say the smoke sensor, if I'll talk about, so those smoke sensor we have to place in the building, and all those smoke sensors are nothing but, if it is connected with the microcontroller, it is called sensor node. So the sensor, individual sensor will become sensor node, means it has the computing capacity, it has the processing capacity, it has the capacity to store the data, it has the capacity to send and receive the data. It is only possible if we'll connect any sensor to these microcontrollers. And if we connect the sensor to the microcontroller, it will become sensor node. And many sensor nodes will become wireless sensor network. So this particular part is nothing but is called wireless sensor network. So this part is wireless sensor network. So and these sensor network has the ability to communicate with each other, as well as they can communicate it to gateway node. And what is this gateway node? Gateway node is actually working in between the wireless sensor network and cloud. So the gateway node is a node, a particular computing device which is actually connected with the internet. So you can see the sensor node is actually not connected with the internet. Sensor network is not connected with the internet. Actually, if I want to connect, it is possible, but generally it is not going to connect with the internet. Let's say if I take an example, let's say a smart watch. Okay, this smart watch has many sensors. It can sense my heart rate, so it can find it out what is my heart rate is. It can find out like how many steps I walked, how many calorie I burn. Based on that, it will what type of exercises I have done, how much time I was in the car, how much time I was working out. So all these things will be monitored by this smart watch. And do you think that this is connected with the internet? No, it is connected with the mobile phone. So it is actually connected with the mobile phone, right? And this mobile phone is actually connected with the internet. So you can see this is a sensor and this is a gateway. So this is a sensor node which can do processing and can communicate the data to the gateway node. And this gateway node is actually connected to the cloud. So let's say if I have a MI watch, and this MI watch is connected with this particular phone with the Bluetooth technology, and it will send the data to here. And here I have an application which is an MI application, and through the internet I can send the data of all the data which is received by this smartwatch to the cloud of MI, right? So it is working as a gateway, and this particular gateway is nothing but a bridge between, or a bridge between, or an interface between the wireless sensor network and the cloud. And in the cloud we actually send the data, to the cloud. So about the gateway node, we get to know that it is a computing device. Any computing device which is connected with the internet, and these computing device can send and receive data to the wireless sensor network. Now, the next thing came is, what do we mean by a cloud? So as our whole theme is about cloud and what is the importance of cloud, what is the need of cloud, so I'll explain this particular cloud in a bit detail. So let's see, what do we mean by a cloud? So everybody are talking about cloud and cloud, right? But what is actually cloud is? So let me tell you what is cloud. Cloud is a computing resource available remotely. Cloud is a computing resource which is available remotely, and we can access cloud through the internet. So if we have an internet connection, I can access my computing device which is somewhere remotely placed. Okay, now what are the work of the cloud? What cloud will do? So as IoT does two things, cloud will also do two things. So it is very simple. Now cloud has only two things. The first thing is cloud is going to store the data, and second thing is cloud is going to process the stored data. That are the two things of the cloud. So the first thing is whatever data it has taken from the gateway node. So what it will do? It will take these data from the gateway node, and these data it will send it to the cloud, and this particular cloud will do the storage and do the processing with those data. Now when we say like what is the processing and how it will be done, so let me tell you, the processing of the data will be done with different type of analytics. Analytics means here comes the AI ML algorithm, different data sciences algorithm that will run in R, Python, and many other these data sciences tools. So here we have to install those tools, and we have to use some analytics to actually analyze the data and which is stored in the cloud. So why we required this analysis? So analysis is actually required. Let's say let's talk about the same example. Let's say I have a smartwatch, right? And I have MI app here. And what this MI app will do? MI app will capture all those data and send that particular data to the cloud. Okay. And what cloud will do? Based on your exercises, based on your steps, it will do some analysis. Okay. And then what it will do is it will give the results. So if I talk about this like the MI app, so it will tell you that how much time you slept, what are the timing that you have slept in a good way, how much time you are not sleeping very well, how much calorie you have burned, how much step you walk, how many other people are there which are ahead of your working, ahead of your steps or ahead of your work, and also all these analysis will be done based on your heart rate. It will tell you like you are in danger or you are not in danger, your heart is perfectly working very well. So all these analysis, how it will be done, it cannot be done here in the watch, it cannot be done here in the phone, it will be done in cloud. So cloud has two things. First, it will store the data, and second, it will process the data through some analytics, through some analytical algorithm that will apply in the cloud. It is based on your need, your requirement. So this is the work of this analytics or analysis. Now, after doing the analysis, the results, whatever results it is producing, it has to be sent to the user, because ultimately who use the IoT infrastructure? Who use the IoT infrastructure? So the IoT infrastructure will be used by any user, right? Any user, any human being, right? So how it can see what is going on in my IoT infrastructure, right? So the answer is it can able to find it out that what is going on in its IoT infrastructure using some user interfaces. Now, what do we mean by user interfaces? Now, the user interfaces is maybe your application. So as we have MI application with us, so that application will tell me that what are the results that cloud is giving you, right? Second, I have some websites in which I can go and I can see what is the cloud results are. So I can open the website and I can see what the result cloud is giving us, or with the help of some SMS or some WhatsApp messages, right? So that is called interface. Means how a user will get to know what is the result of the cloud. So what is the result of the cloud? It can only be visible through the user interface, and user interface could be anything. So it might be your application, web application, or your Android application, or your other mobile OS applications, or yeah, SMS or the messages. Okay. Now, if you'll see the link between all those components, so all those component has the link which is you can say it is not a directed link, it is an undirected link. Means the data will flow that side, as well as data can flow that side. It means from here to here, if my data will be flowing in that particular direction, if my data will be flow in that particular direction, so you can see that this is what monitoring. And from user are want to access anything, so any data will go to the cloud, and from cloud it will the data will go, or the signal will go to the gateway node, and from the gateway node the signal will go to my sensors, the sensor node, the actuator. Then this particular is called accessing. So monitoring and accessing, two things are there, as I told you. So monitoring will be done by in one way, and the sensing will be done by another way. So this is how your infrastructure, IoT infrastructure will takes place, and this is an example of IoT infrastructure. And any of the component is missing in your infrastructure, so we cannot say it is a IoT infrastructure. So we have to talk about much related to cloud, and we'll see that how actually this wireless sensor network works, how this gateway works, and how we can do some data storage in cloud, how we can do analysis, and how we can use the interfaces to do that. So in this whole 3 days 3 day sessions, I'll start with this part. I'll start with the thing part. So we'll see how this thing part works. Then we'll see that how this how we can connect the the sensor node to the cloud, and how we can send the data to the cloud. And after that we'll see that how we can make the interface, and how we can monitor from the user perspective, and how we can control uh, through the user perspective. And at last, in the very last session, we'll see that how we can set up cloud. If it is not connected with the IoT, if I want to use cloud separately for other purposes, so how we can do that. So all these things we are going to see in this webinar sessions. Now let's talk about, we have seen that, let's talk about the need of cloud, that what is the need of the cloud, and why it is useful. So the first thing is the amount of big data that is generated by IoT. So let me tell you, there are many data which are actually generated by the IoT infrastructure, and all those data are of big amount. Okay, and we can say that it is generating big data. What do you mean by big data? What do you mean by big data? Big data is nothing but we have some properties of big data. So there are mainly, we can say that 5 V's, or somebody say 6 V's. And so previously the big data will be recognized with 3 V's, that is velocity, then volume, and then variety. Okay, so it is like that. So big data, if I have a big data, how I can say that it is a big data? So big data has great volume that is done by these IoT infrastructure. Means, let's say if we have the application of smart city, And in the smart city, we have a smart transportation system. And to enable the smart transportation system, we have connected CCTV camera in all over the traffic signals. And these camera are giving us the live feed of the traffic. And from there, actually, we can analyze many things. So how much amount of data these CCTV camera are making? So this camera is nothing but a sensor, right? So sensor is generating data, that is your uh, video data, and this particular video data, we are fetching it, we are analyzing those data, and the volume is very high. If we'll talk about velocity, so how quickly we are getting all those data, how fast we are getting, or this sensor nodes are generating those data is also a factor. And variety, from the variety of sources we are getting the data from the different sensors. We have soil sensor, we have moisture sensor, we have temperature sensor, we have humidity sensor, we have light sensor, we have pressure sensor, we have smoke sensor, we have press uh, IR sensor, motion sensor. There are different type of sensor. They are generating the data, and all these data comes from heterogeneous sources, right? So if I am getting the data from the heterogeneous sources and in the form of structured and unstructured data, so the combination of all these three V's are called big data. And the IoT infrastructure is responsible for generating big data. Big data is generated. Is it possible to store all those data in local computer and process it? No, it is not at all possible nowadays. That's why we need cloud infrastructure to enable all those things. The second thing comes into the picture is a lot of stress is put on the internet infrastructure. This is also a factor why we need cloud. We don't want to put more stress on internet infrastructure. Instead, we give these data to the cloud, and the cloud will do the processing and get the results. Increase load. The load has been increased in terms of volume of data, in terms of need of processing those data. So because of that, actually we need cloud, and cloud is very much important in IoT. So if you take any IoT infrastructure, you take any of the application of IoT in, let's say, smart city, all are connected with the cloud. If we'll take some example like smart traffic management system, we need cloud. All the feed we have to send into the cloud and do the processing. If we'll talk about a smart waste management system, so all those dustbins and all we have to connect with the internet, and we have to locate all the trucks who are loading those dustbin, and we have to monitor all those things very minutely. We have, let's say, water management system. We have, let's say, a smart grid where we can do a good power management system. Or let's say we have a smart hospital management system or healthcare systems where different hospitals are actually connected with each other. They can actually send their diagnosis information to the cloud, and from the cloud many other hospitals nearby can easily find it out. Let's say if I'll take an example of blood bank. So let's say in Bhubaneswar city, all the blood bank are connected with each other. So they will send their blood bank information to the cloud. And from the cloud, anybody can get to know that where that particular blood of that particular group is available right now. And it is very easily to monitor all those things. It could be a life-saving application, right? So all these are possible through the cloud. If cloud is not there in IoT, I cannot say IoT infrastructure can be complete. So it is incomplete without a cloud. here it is another sentence. It says that cloud and IoT both complements each other. How they complement each other? So IoT, what is the work of IoT? So generally IoT generates lots of data, while cloud handle those data in terms of storing the data and in terms of processing those data. So this is the use of cloud in IoT infrastructure. Let's talk about how they will complement to each other in more detail by doing the analysis of what is the cloud advantages and what is the IoT advantages, what infrastructure they are using, whether they are opposite to each other or they are just using the same. So if I'll talk about big data, so in IoT act as a source of big data. So IoT act as a source of big data, but cloud computing act as a way or a mean to manage those big data. So managing the big data, and it is a generating of big data. It is this is responsible for generating the big data. Now the next thing is the reachability. Reachability is limited here, very limited. But here the reachability is far spread. Let's say the reachability means if I have an infrastructure, let's say IoT infrastructure available in the border area. Let's say in the India Pak border, we have motion sensors, and these motion sensors are generating the motion information if they will find any motion, and they will send these data to the cloud, and from the cloud all the troop members can able to know that in which particular location they have find it out motion. So so what the motion sensor will do is it will generate the signal, and the sensor node will generate the GPS information by the GPS again, the sensor, GPS sensor, the location of that particular sensor where it is gone, right? So you can say that Internet of Thing, the reachability is very limited. I cannot reach to the sensor, the Internet of Thing infrastructure all the time. But the data that is given to the cloud, I can always reach through the internet. Storage. Here we can say that we have limited and almost none storage. So in the IoT infrastructure, in the wireless type of thing, we cannot store anything. But in the cloud, we have large and virtually never-ended resources which are available. Now, what is the role of internet in Internet of Things? It as a point of convergence, and here it act as a as for the delivery services. So the usage of internet are different in the IoT in the cloud. Now, if we talk about cloud computing capability is limited, here we have virtually unlimited capability in the cloud. Component run on hardware component, and here run on virtual machine which imitate hardware component. So we have some virtual machines available in the cloud infrastructure which is given by the cloud service provider, and it is actually unlimited resources, unlimited hardware, and what you can say hardware and the processing capacity is unlimited here in cloud computing. But here if we talk about the wireless sensor network infrastructure of IoT, here we have limited hardware component, or the resources which have in terms of computing, in terms of storage is limited. So in that way you can say that they are complement each other. Now let's see why cloud is essential to the success of IoT. What is the reason that a cloud is actually important, and why we can say that if I want to make the IoT infrastructure successful, I should have a cloud infrastructure with me. So just like cloud computing is built on the principle of speed and scale, so So cloud computing can scale its resources, and the speed of computing is very high. So speed and scale are the two factors related to cloud. IoT applications are built on the principle of mobility and widespread networking. Widespread networking. These are the principle behind IoT, and these are the principle behind cloud computing. But the widespread networking is not at all possible without cloud computing. In addition to this, here are a few more points. We'll see why cloud is important. So for the first point is it provides remote processing power. Yes, it will provide remote processing power. Let's talk about the smart camera. Let's say the MI cameras are there, right? Which is a standalone camera, but it is connected with your Wi-Fi, and you can just install the application of MI camera, and you can actually see the live feed of your home from anywhere. So how it is possible? So that device will not do anything. That device will just generate the video and send this video to the cloud of MI. And from the cloud, I am remotely access that cloud using the mobile application of MI cloud, and I can see that how it is doing. And it can do that particular processing remotely and tell me that what is the result. Provide security and privacy. If I am using the cloud infrastructure for IoT, definitely my data is more secure in cloud and privacy will be maintained there. These two terms is, let me tell you, it is not at all applicable in all the scenario, but yeah, in somehow the security and privacy will be preserved of my data. Removes entry barrier of hosting provider. So we have a cloud computing infrastructure available, which anybody can use it. So it doesn't require any entry barrier, right? Facilities inter-device communication. Who did do that? Cloud will do that. Inter-device communication it can easily do. So from one device to another device, it will send the signal, and it can make them communicate with each other. So there are some reasons why we required cloud, okay, in the IoT infrastructure. Now, if you say that no, I don't want cloud, yeah, it is possible. Like if you make your local computer as a cloud, or your local server as a cloud, yeah, it is possible. But again, cloud is important, or cloud is required, whether you are making it locally, or you are using a remote cloud, or you are making a cloud locally. So cloud is there, right? So all the time cloud is there in your IoT infrastructure, and it is important. So as we have gone through many things related to cloud and many things related to IoT till now, I understand that all the thing that I told you, you might not get it, but yeah, somehow you got the idea that what do you mean by cloud and what do you mean by IoT. Now let's talk about some applications of IoT, because without applications, I think any technology or any infrastructure is of no use. If they doesn't have any application, so I don't think so that it is of useful one. So let's talk about some applications of IoT. The first application is smart home. Can we make our home smart? Smart means let's take an example of a smart home. Let's say I'm entering into my home, and it will once I'll get into my room, it will find out, the sensor network will find out my presence, and it will on the light if intensity is light intensity is low, and it will on my fan or AC if the temperature is high, right? And when this room is not occupied, it will off all the appliances. So can we do that? Yes, we can easily do that, and that is an application of IoT as a smart home. So it is a smart home application in IoT. The second thing is wearable. Wearable, as I told you, I have one variable, right? Smartwatch, and there are different other variables which are there, and these are also an example of IoT. Smart city. So as I told you, many applications related to a smart city, let's say transport management system, parking management system, waste management system, the healthcare infrastructure management system. We have smart grid, which is for power communication, smart power distribution system, or water management system. So all those different systems are the part of smart city applications of IoT. Smart grids, yeah. So a smart grid, just I told you, a smart grid is only this the power distribution. So how we can make a distribution of power, electricity, smartly. So that can easily be done with the help of a smart grid concept. In the smart grid concept, these traditional electricity meter will be replaced by smart meters, and this smart meter will actually see what is the usage of your home, and how we can actually do the processing of usage of the electricity in your home, and these information can be sent to the grid from where actually the electricity supplies, and based on that it will visualize that in that particular area this much of power consumption is there, and in another area this much power consumption is there. So based on that it will distribute the load, right? So smart grid will useful for distributing the load of the electricity, and it is a path breaking application of IoT. Industrial internet, we have heard about like IIoT, like internet, industrial internet of things. So industry, in many industry, they have used the applications of IoT now. You might have heard about the technology called Industry 4.0, in which the major part is IoT. So you see the application of IoT in the home or in the smart city, it is okay, but it is playing many roles in industry, in factories, in offices, right? So from the, let's say, the machine monitoring to the room monitoring, let's say we have different gases available on that particular chamber, so it will tell us that do we have any poisonous gas leaking was there, and if it is there then it will give the alarm that there is some leakage of the gas, the poisonous gas, and we can easily identify where the fault is. So nowadays, the industry are moving towards IoT applications, and they are actually moving around the how we can make our industry, our factory, our offices more smart. Connected car, it is also an application, like we are talking about autonomous car or driverless car. It is only possible with connected car. That application is called IOV, Internet of Vehicles, and based on that I can find it out like how many vehicles surrounded me, what is the speed of those vehicles, where they are going, where they are moving, what are their path. Based on that I can find it out like what is the safe path to move, right? So that all can be done with the help of IoT. Connected health, we have a healthcare system, Internet of Health management, or Internet of Medical Health, or the medical of thing, right? So all those are the application of IoT. We have a smart retailing system in which we use the application of IoT. Smart supply chain, that if I, let's say I am a factory and if I'm making up one product and I'm taking the raw material from different sources, so that all can be monitored using the IoT application. Smart farming, it is emerging in India. Smart farming phenomena is actually emerging in India, and many good farmers, many who can afford, actually they can using it and they are benefited. for that particular initiative of IoT, the smart farming and all. Let me tell you one application. Like here, there is a government of Odisha. They have given uh, what we can say water pumps to different fields. Okay, and they used to dig a hole and they will put the water pump there, and this water pump is actually enabled with solar panel. And so they have come up with a project like how we can monitor and how we can see the status of all the solar panels that a government will provide, and can we get to know the health of uh, these water pumps. So this is one application which is very much related to IoT. So they have come up with the idea like every data will go into the cloud. And what data? The data of the how much time will be there to generate a good amount of electricity, so that the power can be on for the motor. Because to on a power we need to on a motor we need more power, and after that gradually the voltage will be gradually calm down. So at a peak time of a day, we need to on the motor, and we need these current and voltage, and how much time it is taking, how much water it is taking from the earth. All those data will be there, and they can actually monitor their assets, right? And whenever they find that the solar panel is not working, or the pump is not working very fine, they doesn't have the good coordination, so actually they can locate those assets what they have given to the farmers, and they can actually maintain them. Instead they give these assets to the farmer, and they forgot they are using that facility, so that they can monitor it, they can maintain it, so that the farmer will be benefited for a longer period of time. So this all these things are possible using IoT infrastructure. You can see there are a huge humongous amount of application. You just think that thing is actually possible. Okay, so actually, I have done some webinar related to IoT applications in post-COVID phenomena, and that webinar is actually available in YouTube. So you can just write my name and write IoT. You will get my channel, and you can actually see that. On that, we have discussed applications of IoT, which will help in this COVID-19 pandemic situation in today's infrastructure, that how we can help through this IoT technology, and how we can make different applications in the IoT technology. So if you want to do any project, or if you want to communicate this to the students, and a student can find it out like, yeah, that can be possible in today's scenario, then yeah, you can go ahead on that. So you can just go to the channel, and I urge to all of you to see that particular video, so that you'll get to know that what are the different other applications that are possible through IoT in today's situation. Okay, now I'll show you something in practically, because today we have around 1 hour around we have done with the theory part, so it become somehow bore, and we even though we have learned many things, but yeah, so if I'll continue to go into the theory part, definitely it will bore you. So whatever I told you just now, let's do practical. Let's do practical and try to understand that how it is happening, and what we do so that it is possible. So all those things we'll see, and we'll see the cloud part also. Okay, today we'll see some glimpse of cloud part also, means how we can send the data to the cloud, and this cloud will store those data. So that thing we'll see. Before going to that, let me introduce you what type of devices I want to use. So here I am using a Node MCU. If you can able to see me, this is the Node MCU microcontroller, which is available, and it is also available in your screen. Okay, this microcontroller has many pins available with us. All those pins, if you see this particular pin, because we have to somehow some basic knowledge should be there, then only we can do the practical type of thing, and we can see that how actually it is happening. So you can see here from this particular side, from this side up to this side, means we have different pins available in this particular from up to down. All these pins are there, right? So all these pins are useful, and here also we have different pins. So all these pins are available with us to connect sensors and to connect actuator. These are different pins, that is called GPIO pin. Okay, and there are number which is there 16, 5, 4, GPIO 0, GPIO 2, in that way. So all these pins are called general purpose input output pin. So we can use this input output pin to connect the sensor and to connect the actuator. So GPIO means general purpose input. We can make it input, means we can take the input from the sensor, and output means we can give signal to the actuator. So it is useful for both. Then we have some pins which are some 3 voltage and ground pin. This is the pin useful for giving the power to the actuator or to the sensors. So we'll give the power here. This is a positive supply, and you can say the ground is your negative supply. So positive and negative is required for making any sensor enable to work. Okay, and here also we have ground pin and the 3 voltage pin. Here also we have 3 voltage pin and the ground voltage pin. If I'm using any type of analog sensor, so I'll have this analog pin. These are all reserve pin. Again, we have GPIO 10 and GPIO 9 pin. We have some special purposes pin. These 4 are some special purposes pin. We have some enabling pin. We have some transmission pin, V in. So this is for voltage in. It will work in a micro USB port. So we put the micro USB port here to give the power to this microcontroller, or we can give the voltage here with this pin also. So in both the pin is going to work to give the power to the microcontroller. If you see this part, this is the actually heart of this node MCU. This is ESP8266 microcontroller, which is my Wi-Fi enabled. It means we can actually connect the Wi-Fi of this microcontroller. Means we can connect the sensor as well as we can connect it to internet. So you can see it will act as a gateway node as well as it will act as a sensor node. Here we have the microchip. It is also for the programming. We have a reset button here and we have a flush button here. Reset button, if we have some program which we have put it here in the hardware and we want to reset it, we can do that, or we can want to flash it, we can do that. So this is a brief introduction or the idea about the chip, which is called Node MCU. Node MCU, and the microcontroller inside is ESP8266, and it is Wi-Fi enabled. Means we can connect this device to Wi-Fi. So what I'll do is I'll use here a sensor which is called DHT sensor. You can see in the slide also, and you can see in my hand also, like this is a sensor. Okay, in this particular sensor we have 3 pins. 2 pin is for power and 1 pin is for data. Means we can get the data from this sensor. What is this sensor? This is called digital humidity and temperature sensor. Means it will generate humidity and temperature of the surrounding. Means where we put it. And this particular data, it will send to the GPIO pin. So one of the pin is connected. So this is how your pin is. So the middle one is your data pin. The middle one is your data. Okay, here it is somehow wrong. So generally the middle one is your data pin, which is connected here, and one pin is with the positive voltage, another pin is with the ground. So this is how we can do the connection. So let me tell you how we have connected. This is the node MCU, and this is the sensor that we have connected, and this is how we have connected to it. So we have a pin here, which is a middle one is the data pin, and then VCC pin and the ground pin. So in that way we can connect it. We give the power to it. What it will do? It will sense the surrounding, or it will the analog signal, it will convert into digital form. It will give it here. So what it will give is, it will give the temperature and it will give you the humidity. These two value it will give us. So let's connect it to the computer and write some code on this particular microcontroller and see how it works. Okay. So you see, I have different programs available for today. I have some program which are available. So let's say I'll open one program here. This is a program which will be useful for collecting the data of the microcontroller. So I think you can see the code right now. We have used dht.h, which is a header file for that, because every device should have some enable device drivers, right? So it will work as a device driver. So this .h is using that particular DHT sensor. So this is of type DHT11. And for this particular microcontroller, we have used ESP8266, which is, as I told you, ESP8266 Wi-Fi is required here. Then we have defined a pin, which is D2 pin. If you'll see the diagram of it, where is the diagram? Yeah, so this is the diagram where you can find it out. We have D2 pin here. This is D2. Okay. Yeah, so if you'll see here, this is the pin, which is D2 pin, general purpose input output pin 4. So this is the pin where I have connected my device. Okay. Yeah, so and then we have some functions to it. Here in this particular environment is called Arduino IDE. It is an IDE for the Arduino board, and Node MCU board is also working in the same IDE, and we can write the program in that way. So you can see the program is just like our C++ programming, and it is very easy to do that. Now here, if you see what we have done is, so here we have in the program of Node MCU, we have actually two functions. One function is called setup function, and another function is called loop function. So the setup function will run one time, okay, and the loop function, whatever there in the loop function will be actually working endlessly. Means it will be halt once you remove the power. So all the codes which are there inside the loop function, that is the code which are there here, which is a highlighted one, is nothing but it will work continuously till you remove the power from the microcontroller. Okay, so let's see this. What is that? So first is the setup function. In the setup function, we have defined a serial monitor. So in the serial monitor, we'll just define the baud rate. What is the baud rate of the serial monitor, which is this highlighted version. And then we'll just begin the DHT sensor. So we'll just enable the DHT sensor here. And after that, there is a delay. Delay means we have to wait for some time so that it will execute the next one. So that's why the delay function works. Now after that, come to the loop part. So in the loop part, what we do is we read the humidity from the DHT. So we'll use object DHT dot read humidity. Read humidity is a function to read the humidity of the environment, and DHT read temperature will read the temperature of the environment, and these value will put into some variable. So you can use float variable or long variable or int variable, just like your C++. Okay. After that, we have some codes. The code says that there is a serial dot print, means we are just printing these things. What we'll print? Current humidity, and we'll print the H value, which we just find it out. What is the humidity? And we'll do the temperature also, and we can see what is the temperature it is producing. So what I'll do is I'll just connect this particular setup to my computer, and I'll put the code into that, and we'll see how it works. So I'll see that whether it is connected to. Okay. Okay, now it is connected. Now I'll put this particular code to the microcontroller. So here in the bottom, which is darker right now, here you can see that how my data is coming into the microcontroller, and see the power has been given to the DHT sensor. So it is the light is there. It means I have given the power to the this particular sensor, and this sensor it is attached with this particular microcontroller. Okay. And first of all, it will do the compilation of the code, and after compilation it will put the code into this microcontroller, and this microcontroller will work according to our code. So our code says that get this particular humidity and temperature data, and put and give this particular data and show us into the serial monitor. So if you can see that it is loading into the uh, device, and it will take around 10-15 seconds to load. So you can see meanwhile it is blinking. It means some data is going into that particular microcontroller. Okay. Now it is 100%. You can open the serial monitor. This is where we have the serial monitor available. So we just click the serial monitor. You can see after some time the data of the humidity and temperature will be flash here. So just wait for some time. It will come here. So here what we have done is the delay of getting that data is actually 2 seconds. We have done this particular delay as 2 seconds. So why I'm showing you is this is what is the problem? It should show. So here we can actually adjust the baud rate. Baud rate we have fixed it so that your device and the serial monitor can communicate and can send the data here. Okay. Okay, let me do the same thing again. I'll just reduce the delay to half of the second. So why I'm telling you is, first I want to tell you about this, and then we'll see that how we can send this particular data to the cloud. So that I want to show you. And here we are going to use actually two cloud platform. One is, so 100% is completed. Let's see whether it is coming or not. Okay, please bear with me. I don't know what is the problem here is. So once this will be in a working condition, we can actually, what we can do is we can send this particular data to the cloud. Okay, still. Okay, let's try two other codes. Okay, we'll come to that. This is another program for you. I made it. Like it will find out the signal strength of the Wi-Fi, because as I told you, it is connected with the Wi-Fi and we have the Wi-Fi module. So I want to know what is the strength of the signal that it is having from the access point. Okay, okay. I got the problem, I think. Hotspot was not on. That's why it is not giving the value. Yeah. So no, hotspot is on. It means it has the connection. It will make the connection to the internet. Let's see. Yeah. So you can see that it is connected with the internet, and it's saying the IP address is 192.168.43.94. This is the IP address given to the microcontroller, and this is the current signal strength it is giving us. So this signal strength, definitely it has the Wi-Fi enabled, so definitely it has the capacity to find it out what is the signal strength. You can see it is coming in milli-decibel. It means this particular unit is to find it out what is the strength of the signal. And when we convert this milli-decibel to watt, so we'll get some positive value. Here it is coming negative value. It doesn't mean that it is a negative. Okay, actually it is a value that is giving, and if we'll convert into watt, so definitely some positive value will come. Now this is one example where we have captured some values here. Okay, let us try to do that particular recent thing that we have tried to do is DHT, because it is working very fine. You can able to see like signal strength. It is visible to all of you that signal strength, it is fetching up at every 2 seconds, and you can see the fluctuation in the signal strength, right? So this is we have done. See, what we doesn't need any sensor. Sensor is inbuilt for the signal strength. Okay, this is the same program that I was trying to do. This is the DHT sensor program. So let's see whether it is working this time or not.
Yeah,
So what the sensor will do is this sensor will generate the humidity.
Sir, I request Haitham sir to mute yourself, please. Hands-on session is going on. Haitham Mohammed Abdul Wahab Ahmed sir, please mute yourself. Hello, Abdul sir, can you mute yourself?
Okay, now it is coming. If
you
can able to see.
Yes, yes. Sir, okay.
Yeah. Tell me, Tamragar sir.
Yes, sir. It's fine, sir.
I muted everyone, so I was just telling you to unmute.
Yeah. I know that. So you can see that the humidity and temperature value is now coming. The humidity is 52% right now, and the temperature it is showing 85%. 25 degrees Celsius. If I blow some air to it, so let's see how the humidity and this temperature used to change. So you can see the humidity is increasing, right? So it is now 53, 61, and 58 is coming. And I put some hot air, so the increase of temperature also you can see that from 25 it is going to 26. So, and this humidity has also increased to 60 and then slowly coming down, and it is giving you the value. So what is the application of it? Like you can use this thing in your, let's say in your garden, or in your let's say the any plant, or you want to monitor the humidity of or temperature, or you want to monitor the humidity of temperature or home room, or you want to monitor the temperature of your home, or you want to monitor, let's say the fire value of your home, or the light intensity of your home. Everything will come here, right? So this is one way how we can get the sensor data. So this is generating the sensor data at every 0.5 second. It is generating it. So you can see that how quickly it is changing the value, how quickly it is generating the value. Now, second thing we'll see is how we can send these data to the cloud. So first part we have done, means the wireless sensor network part, and the part we have done, like we have generated the sensor data and we have put it these data, and we can see that, okay, from that particular microcontroller. Now could we connect this to internet, and actually we can monitor these data to the cloud? So yes, we can do that. So let's go to the cloud which we are going to see today. So we are going to see today two type of cloud. First is thingspeak cloud, and the second one is Google Firebase Cloud. About the thingspeak cloud, this is a IoT cloud platform given by this particular IoT platform given by MATLAB. So this is produced by MATLAB. MATLAB is a company who is providing thingspeak cloud. We all know what is MATLAB is, because we all have done programming and the coding and generated the graph and done some image processing type of thing in MATLAB. So we know what is MATLAB and what it can do. And then there is a Google Firebase. So Google also provide us IoT cloud in which we can actually send the data. So first we'll see thingspeak, how it works, and then after that we'll see Firebase, how it works. So first we'll go to the thingspeak. So this is the thingspeak. If you'll see the right, it came right. So this particular is this particular is thingspeak. Here we have the URL of the thingspeak, which is thingspeak.com. In this particular cloud, actually you can create what you can do is you can create your account, and after that you are able to create the channel. Create the channel means in that particular channel your data will come. Okay, so we have an option called new channel. So once we have registered in this particular cloud, after that, what is the second thing we have to do? We have to create the channel. So for that, we have a button, create channel button. Now here, when you open the cloud and when you sign in, here we have some examples. So here you can see there are some example code which is there, like Arduino, Arduino MKR1000, Node ESP8266, Raspberry Pi, Arduino Plus. For all those microcontroller, we have some example program which is there already. Now let's go to this new channel part and try to understand what is this. So when we click the new channel, we'll go into the channel of it, and then there are some fields that we have to fill. So the first field is name the channel. So let's say I'll name the channel, and I'll write it DST sensor, and I'll write down webinar. Okay, so what is the description? Description is it is not essential, so you want to give or you don't want to give, it is up to you. So I'll write down just DST. I want to fetch the digital humidity and temperature data here. Now here, how many fields are required? So I require 2 fields. So let's say the first field, I'll put it like humidity. I required humidity, and the second field also I'll enable, and I'll write it here. I need temperature here. Okay, so I need 2 fields here. So I have done 2 fields, and I'll just save it. Okay, I'll just save it. So one channel has been done, and you can see here I have 2 graph here. There is no value in the graph. Value will come once we'll connect this particular cloud to our microcontroller. So how we can do that? For that, we need the API key. So there is a key which will be produced here that is called write API key. Write API key is to write the data into the cloud. So this API key I have just copied and I'll paste in my program. So I'll open the program. Okay, this is my program. I'm just opening it. So you can see in my program, I have a part is called secret write API key. Here I can put that particular API key. So here I can just copy and paste. Yeah, so the code has been pasted here. You can see that. So now this is a same API that is there in the thingspeak. Okay, same API key I'll use here in my program. Yeah. So if we'll come to the program is almost same. There is a D2 pin which I have enabled for the taking the data. Here I'll use my local Wi-Fi where I'll connect it, and then I'll just fetch the temperature and the humidity. So I'll just fetch the temperature and the humidity from the sensor, and after that I'll put those data to the thingspeak. So in one channel I'll put humidity, and in another channel I'll put temperature. Okay, so let's do one thing. Let's yeah, here it is 2 seconds. So every 2 seconds it will update this particular data to the channel. Okay, now let's upload this particular program to the node MCU. So I'll use I'll see whether it is connected or not. Yeah, port. So let me connect the device, then port will be enabled for it. Yes, it is enabled. The USB is enabled right now. So it is enabled. Now I can go for uploading. So this is one button where I can upload it, right? Or yeah, so that I can do. So I'll just upload it. I'll just check in my phone hotspot is on or not. So I'll just on the hotspot right now, so that once this program will be uploaded here, my this device means my microcontroller will be connected to my phone, and it will get the internet connection. And through internet connection and the API that I have given, it will send the data to the cloud, and that particular cloud data we can see. So now it is uploading. If you can see in your screen, it is coming, is uploading. So you can see I have this setup. So where this is a microcontroller, and here we have a DST sensor which is there. To connect it, I use some jumpers, and I have connected it. It's very simple. Just 3 pins are required to connect it. Yeah. So 100% connected. Let's see. Yeah, it is showing connected in the, and humidity it is showing 55 and 25. So let's see in our thingspeak is it is showing or not. So if you'll see the thingspeak, the data is coming in the form of graph. So I think you all able to get the dots here, right? So this dot is coming, let's say 12:52, 38 second it is coming, and this humidity value is also coming. So once you will get some different values here, in every 2 seconds you will get the values, and you can see with the help of this graph. So once you will wait for at least 15 to 20 seconds, you can able to see there are many data that will come slowly. So these data are coming into this cloud, and actually we can visualize it. So you can see this is the interface where I can monitor the temperature and humidity that is there somewhere, right? And this you can open.
Sir, please unmute yourself. Suraj sir.
So this is how we can see the real-time data into the cloud, which is going around. And in that particular, if we'll talk about the data that is coming, you can actually get the data also. So it will save the data in CSV file, and you can just download those data afterwards. So it is based on your project, what project you are using. So you see that the temperature, the humidity was 55%, and after that it was changed to 53%, and the temperature is still 25%. Let me change some values here so that you can see the spikes on it. So you'll see slowly some spikes here in the channel, and I think it is visible to all of you. Now, if you want to change something here, let's say here it is showing humidity, here it is showing date. So you can actually edit that particular chart or the graph. So you can give the name of the title of the chart by just editing it. So humidity, X value is date and time will give. Y value we can give to humidity percentage, and yeah, color, and what type. Let's say that we are using line. Can we use spine? Let's see how the data will be visualized in the spine line. So you can see this chart is showing like a spine, right? It's showing some values. So I have blown some air here. That's why you can see the humidity has been changed. And I want some change in this temperature also. Here also I can add it. Let's say it is temperature. The x-axis is date and time, and the y-axis is temperature. And let's say I'm changing it to, let's say the column. Let's say I want to change it to the column. So it will show us in the column form. See, if you can see that it is showing in the column form, and it is putting some values like it is 28, 27, it is 25 in that way. So you can actually visualize the real-time data into that particular cloud, and it is storing in the cloud. Okay, I have changed it to line. It is coming in the form of line. You can add some gadgets here, like you can add some gadgets. Let's say the numeric value you want, so you can put numeric value. You want to fetch the numeric value from the field 1, which is giving you the humidity. That you can do. Yes, is okay. Then here if you'll see, this value is coming. This is a humidity value that is coming here, that you can see the humidity value is coming. Or you want to add some more wedges, you can do that. Let's say you want to have the gauge type of thing, that also you can do. So first, let's say the numeric value, we can go to the temperature, and we'll put the temperature here from the field 2, that we can do. Then create. Now after that, this value will come here. So this is the value for the humidity, and this is the value for the temperature that is given here in the real time. So you can see it will change once the value will be changed here. So I want to change some values here. So maybe it will show you, because every 2 seconds is fetching the data. In every 2 seconds, the microcontroller is getting the data from the sensor and showing you in the real time here. So you can see that now it is 54 and 25. Let's see how it works. So as I told you, this is one example of cloud, okay, where we are sending the data to the cloud and we can monitor it in a very real time. I want to show you the way how we can actually download it. So you can see there is a tab. This value has been changed, I think. It is showing 57, right? 57. This value has been changed to 54 to 57 right now. So this is the graph for it. You can see the real time how your temperature and how your humidity is changing. And yeah, here I want to tell you, there is a tab called Data Import Export tab. if you'll click the data import export tab, which is here, which is here. So once you click it, and you can find it out how we can download it. So just click that data import export. You can see how, if I want to export, I have to do download. So there is a button of download. Once I click the download button, this data, whatever data till now will be given to the cloud, will be coming here in the CSV form. We just open it and we'll see that what data it is giving us. Yes, sir. Yeah, sure. Okay, so this is the feed that I have got. I just want to show you the CSV file. Yeah. So this file you can able to see, right? So in that way, what we can do, we can get the data, we can do the processing if we want locally, or we can do the processing in the cloud also. So I think